Jai Hind and welcome to all. Myself Shiwani from Applied Science and Humanities Department in Ajay Kumar Garg Engineering College is going to explain a portion of Unit 3 which is a corrosion. So, in this lecture I will discuss the causes and effects of corrosion, and for this the references which I have taken again from the same book, Engineering Chemistry by Jain and Jain by Shashi Chawla, and the mechanism is basically I have taken from the CBSE site, that is www.cbseguide.com. So, corrosion means slow deterioration of metal. In early morning of 3rd December 3 in 1984, if we know that poisonous gas MIC get leaked, and because of the addition of water to tank, so it caused a runaway chemical reaction, and which was the exothermic, and resulting in a rapid rise in pressure and temperature. The heat generated by the reaction, the presence of higher than normal concentrations of chloroform and the presence of iron catalyst produced by the corrosion of the stainless steel wall, and resulted in a reaction of such momentum that gases formed could not be contained in safety systems. So, in this again here we see this term, it means corrosion, it may be a part of any accident where the metal is used. There are the various safety measures, and the flare tower, it could not be used because a length of piping it was corroded and had not been replaced. So, the reaction is in this accident, the reaction is accelerated by one factor, also there is again in addition of one factor, and it is corrosion. So, first let us take the definition. So, corrosion means the destruction, deterioration of metal because of chemical or electrochemical reaction, and which is always unwanted with its surrounding environment or medium. That is deterioration or consequent loss of solid material through unwanted chemical or electrochemical attack by its environment and starting from its surface. We can say this process is reverse of extraction of metal, and we see that in case of copper we get the green material or green particle at the surface. So, this is the basically corroded material, and due to copper hydroxide, copper carbonate. In case of iron, we see that it got rusted. So, it may be due to ferrous or ferric hydroxide. So, why this corrosion occur? This is a spontaneous process, and it is the reverse of extraction of metal, because we know that ore which is thermodynamically stable, and through metallurgy we get a pure metal from the ore, and this pure metal is thermodynamically unstable, and this is the law of nature that every unstable thing it acquire or it has tendency to get in stable form. So, this metal also has tendency to convert into stable form. So, it combined with oxygen and form metal oxide, and this process is called corrosion. So, from ore to metal, this is the reduction process, and from metal to combined form, which is a oxide form or corrosion product, this is oxidation process. So, we can say that this is just reverse of metallurgy or extraction of metal. Example, the formation of rust on the surface of the iron, the formation of green film on the surface of copper, and the responsible factors are metal and surrounding, and temperature we can also say the temperature and design. And why this corrosion important? So, there are the effects and which always in negative side. So, first is loss of useful property of metal. So, its efficiency, decrease in production rate, increase in maintenance and production cost, replacement which consume time, and the contamination of products. So, to explain the corrosion there were different theories. The first theory was acid theory, second dry and chemical theory, and third, which is mentioned in AKTU syllabus, is electrochemical or wet corrosion. So, first let acid theory. This theory suggests that corrosion of metal, and let us take iron, is due to presence of acids of surrounding, and according to this theory the iron is corroded by atmospheric gas which may be carbon dioxide, moisture, oxygen, and the products are FeH ferrous bicarbonate, FeOH CO3 and FeOH whole thrice. So, these are three reactions, Fe with CO2 and moisture and oxygen bicarbonate, and this bicarbonate again get converted into hydroxycarbonates, and this hydroxycarbonate again get converted into ferric hydroxide. Now, second, chemical theory of corrosion. The chemical theory, as per this theory, the corrosion on the surface of metal is due to direct reaction of atmospheric gases like oxygens, oxides of sulfurs, nitrogen, H2S, fumes or etc. The extent of corrosion of a particular metal, it depends on chemical affinity, that is tendency to accept of the metal towards the reactive gas. So, among these gases, since the affinity with the oxygen is high, so the oxygen is mainly responsible for the corrosion and the most metallic substances when compared to other gases and chemicals. So, as per this theory, the metal directly react with oxygen in absence of moisture. Alkali and alkaline earth metals react with oxygen at room temperature and form oxide, that is almost the first group member or second group member, and they comes in metal category, because in periodic table if we see that the first two groups they are metals, last 3 these are the non-metals, and between the in between the metal and non-metal these are metalloids. So, generally first or second group metals they have tendency to combine with oxygen and form metal oxides. So, some metals react with oxygen at higher temperature, and some metals they are not oxidized, that is they are called noble metals. So, as per this theory, when the metals combine with oxygen and form metal oxide, that is a thin layer of metallic surface which protects the metal from the further corrosion, and this layer it decides the further corrosion. That is, if the diffusion of either oxygen or metal across this layer is possible, so the further corrosion is there. So, we can say that the layer of metal oxide it plays an important role in process of corrosion. For example, in case of noble metal, that is Pb, Al or Sn, these are not noble, these are basically passive metal. So, the oxides of these metals are stable. As we know that aluminum, it does not corrode, or it has very little tendency of corrosion because of stable oxide layer. So, these Pb, Al and Sn, these form a stable oxide layer, and stable oxide layer means they inhibit the further corrosion, that is this layer act as a protective coating. So, if the question is like this, कि why aluminum does not corrode as per this position in electrochemical series, because of a stable layer of Al2O3, that is alumina. Now, in case of iron, the oxide layer is porous. Porous means the atmospheric gases, it pass through the pores and react with metal, and the process of corrosion continues till the entire metal get corrode. So, in case of porous film, and like in case of iron, the further corrosion will take place till the whole metal get corrode. Now, next, if the layer is porous, volatile, if the metal layer is, oxide layer is volatile, volatile means it form a unstable oxide layer and will get easily volatile or vaporize. So, in this case, the speed of corrosion it get high, that is it accelerates the corrosion. While in case of gold, silver, platinum, and these three metals are used in ornaments. So, these form unstable oxide layer. Unstable oxide layer means it immediately decompose. So, then in these type of metals, the corrosion will not take place. That is, these metals are free from corrosion because the metal oxide layer which formed, it immediately get decomposed. So, I think this is the simple summary. So, if the metal layer is unstable, unstable means no corrosion will take place like silver, gold. If metal oxide layer is stable, it will act as a protective coating, that is it inhibit or it basically reduce the further corrosion. If metal oxide layer is porous, so in this case the further corrosion will take place till the whole metal get corrode. If metal oxide layer is volatile, so in this case it accelerate the process. So, corrosion by other gases like Cl2, SO2, oxides of nitrogen. So, in dry atmosphere, these gases react with metal and form corrosion products, and which may be protective or non-protective. Dry Cl2, it reacts with silver and form AgCl, which is a protective layer, while in case of SnCl4, this oxide layer is volatile, and that is why it may be protective or non-protective. In petroleum industries, at high temperature, H2S attacks steel forming FES scale, and which is a porous. Porous means it basically accelerate the corrosion, or we can say the corrosion process further will take place, but interfere with normal operation. Now, liquid metal corrosion. In several industries, the molten metal, it pass through the metallic pipes and cause corrosion due to dissolution or due to internal penetration. For example, liquid metal mercury, it dissolves most metal by forming amalgams and thereby corroding them. Now, the next is, which is electrochemical theory of corrosion or wet corrosion. Electrochemical, this term shows that there will be a two different metal, and if metal is same, then the concentration of electrolyte it should be different, and the one metal will act as a anode and another metal will act as a cathode. So, this type of corrosion occurs when the metal comes in contact with conducting liquid or two dissimilar metals dipped partially in a solution. According to this theory, there is the formation of galvanic cell. Why galvanic cell? Because two different metals or two dissimilar metals or different concentrations. So, one cathode, one anode, and medium is electrolyte. The chemical in environment and humidity act as a electrolyte, and we know that the oxidation of anodic part take place, and if there is any confusion, we can remember lone. So, loss of electron, oxidation, anode. So, at anode the oxidation take place, so the corrosion always occur at anode, while the reduction takes place at cathode, and the corrosion product, it is formed on the surface of metal between the cathode and anode. So, this is a simple example of electrochemical cell Zn copper, and since the copper reduction potential is less, so zinc will act as a anode and copper will act as a cathode. So, to explain this electrochemical corrosion, here we discuss, or I will explain the two theory. First is hydrogen liberation and second is oxygen absorption. So, first evolution of hydrogen. First, let us take an example. This is suppose iron bar, this, and the most of the portion of this iron bar is open in atmosphere, and suppose this portion it is covered with any material or coating or etc. So, since this portion is open, so this portion will act as an anode in atmosphere. So, this is anodic part and here again, and the portion which is covered, this is cathodic part. So, we can say in this type of mechanism, the anodic area is larger than cathodic area, and in anodic area, since iron is there, so the reaction, the common reaction, it will be Fe, which will give you Fe2 plus 2 electron. And second, in acidic medium, since the H ions are there, so 2 H ion plus 2 electron, which will give you H2. So, first, what is the condition or what is the example? So, let us take the rusting of iron in acidic medium or in acid rain. So, in this case, since the portion of iron is open, so it at anode the reaction will be Fe, which will give you 2 plus 2 electron, and the hydrogen atmosphere H ion, it will formed in acidic environment. So, the second reaction will be this, but this type of mechanism occur where the H2 gas released, that is the metals above hydrogen in electrochemical series can show this type of corrosion, because in this case the oxidation of metal must be there in comparison with hydrogen. So, the metal above the hydrogen, they get oxidized. So, they show this type of mechanism. So, first condition is this, and second condition, H ion must be there. And what will be the combined reaction? The combined reaction will be this plus this, that is Fe plus 2H plus, which will give you Fe2 plus H2. This type of corrosion takes place in neutral, basic or saline medium in presence of oxygen. That is, if iron bar is open in air or in saline medium and where the movement of electron is comparatively fast. So, in this case this mechanism may take place. So, in this mechanism the oxide of iron, it covers the entire surface, and the small scratch or crack on the coating or oxide layer, it will create a small anodic area and the rest of the surface act as a cathodic area like this. So, this is a iron bar, we can draw like this. If there is any problem, we can draw like this. Suppose this is a iron bar and this is a coating or metal oxide, or we can say the metal oxide layer is there, and a small crack, let this crack is there, and suppose crack is there. So, the small crack, it will create a anodic portion. So, this portion will be anodic and the rest of portion as compared to this, it will be cathodic. So, in this case, so anodic area, since the metal is open or exposed in atmosphere, so it will act as an anode. So, the reaction will be common, which is Fe, which will give you Fe2 plus 2 electron. and the electrons are there, and medium oxygen is there, moisture may be there. So, the reaction it may be half O2 plus 2 electron, and there will be again moisture will be there. So, 2 OH minus. So, the combined reaction it will be this, and O2 plus we can write half O2 plus H2O plus 2 electron, that is 2 OH minus. So, the combined reaction will be Fe plus half O2 plus H2O, which will give Fe2 plus 2 OH minus, that is FeOH whole twice, ferrous hydroxide. Now, ferrous hydroxide, and if oxygen is more, then ferric hydroxide may be formed, that is FeOH whole thrice, and which is Fe3O4, a mixture of FeO plus Fe2O3, and it is called brown black rust because it is brown black in color, while FeOH whole twice. So, this is ferrous basically. So, Fe2O3 dot H2O, it is a yellowish rust. And here we see that although corrosion occur at anode, but in this mechanism we see that the corrosion product they collect at cathode, because the diffusion of Fe plus 2 is more as compared to OH minus, because in this 2 ions are there, and when these 2 ions combined, then the rust product get formed, and since Fe plus 2 has more speed, so it immediately leaves its place and combine in area of OH minus, and which is a cathode. So, in case of electrochemical corrosion, there are two mechanisms. First is hydrogen get liberated, that is evolution of hydrogen, and second is oxygen get absorbed. In hydrogen, there are two conditions: the medium acidic, that is H ion must be there, and second, the position of metal in electrochemical series must be above the hydrogen. While in electrochemical corrosion, the condition is the moist atmosphere or in oxygen must be there. So, it may occur in a basic medium, neutral medium or saline medium. And here the main reaction is oxygen plus water plus electron, which may form hydroxide, and these hydroxide combined with metal and form or corrosion get occur. So, this is the difference in chemical and electrochemical corrosion. In chemical corrosion, moisture is not required, while in electrochemical corrosion, it occurs in presence of conducting medium. It involves the direct attack of chemicals on metal surface, and where it involves the formation of electrochemical cell. This process is slow and this is comparatively fast process. Here the corrosion products are formed at the site of the corrosion, and in this process the corrosion products formed at anode. The process of corrosion is uniform and it depends on the size of the anodic area or anodic part of the metal. And suppose one question arises, then find how much corrosion is formed, how much rust basically get formed if suppose 100 gram iron completely rusted away, and let the formula of rust is Fe2O3 dot 6 or 5 H2O, let us 6 H2O. So, in this case rust is this. So, we can find the weight, and suppose weight is m gram, and this m gram rust is formed by 2 moles of hydrogen, and hydrogen is 56. So, it will be 112 gram. So, by unitary method we can easily say that 112 gram iron form m gram rust. So, 100 gram iron will form how much? M upon 112 multiplied by 100 gram. So, this will be the weight of the rust. Now, another type of corrosion. So, there are various type of corrosion like galvanic, pitting, stress and etc. We will in this we will discuss only 2 or 3 corrosion with example. Let first galvanic corrosion. Galvanic means 2 different metal exposed in or dipped in electrolyte, so that they can form galvanic cell, and in this the metal which act as a anode, it get corrode. For example, zinc and copper, when they are connected with each other in a electrolytic medium, they will form a galvanic cell. So, zinc get corrode, while the copper, it will be unaffected. So, this type of corrosion, it can be avoided by coupling metals which are close to electrochemical series, or by fixing a insulated material in between 2 metals, or by using larger anodic metal as compared to cathodic metal. But there are few examples, and the common example is steel pipe. They are avoided to connect with copper plumbing, or steel screws, they get corrode, or they are avoided in brass marine hardware, because steel screw means metal is iron, and copper or brass hardware means the metal is copper, and since water is there, so conducting medium will be there. So, in this case 2 different metal in conducting medium, so they will form a electrochemical or galvanic cell. So, in this case the steel screws or steel pipes, they get corrode, and that is why they are avoided. Zinc coating on mild steel, the same. Lead steel soldering around copper wires. Now, next is pitting corrosion. What is pitting corrosion? Due to the crack on the surface of metal, the local straining of metal, it sliding under load, chemical attack. So, there is a formation of local galvanic cell here, and the crack portion, it act as a anode, and the rest of the metal surface act as a cathode. So, it is a anodic, and we know that the corrosion always occur at anode. So, the formation of pit is observed during or because of corrosion, and this type of corrosion where the pit is formed is called pitting corrosion. This is simple. Now, next is waterline corrosion. It has been observed that in case of iron tank or steel or iron bucket, the portion of bucket or tank just below the water line, it get corrode. So, remember one thing, the portion where the oxygen concentration or supply is less, it will act as a anode, and the portion which act as a anode, it get corrode. So, that is why just below the water line portion, the oxygen concentration is less, and since the oxygen concentration is less, it will act as a anode. So, here we see that the rusting will occur, because at cathode the reaction is consumption of oxygen, and since the oxygen supply is less, or the portion where the oxygen supply is comparatively less or low, so here this reaction will not occur, that is this portion will act as a anode. So, remember one thing, less oxygen concentration means anode, and corrosion always occur at anode. Now, differential aeration corrosion. Differential aeration corrosion, before this let us take an example. The portion of nail which is inside the wall or door, it get corrode, while the portion which is open in atmosphere, it remain the same. The reason behind this, again remember the same point, the portion which is inside the wall, here the oxygen supply was comparatively less, and where the oxygen supply is less or minimum, this portion will act as an anode. So, that is why the portion which is inside the wall or inside the door, it get corrode. The net or wire gauge, or we can say the net of window, etc. So, here we see that the portion which is covered, this portion, so in this portion the oxygen supply is less as compared to other part. So, in wire gauge or a net we can easily see or observe that the portion which is crossed, here the corrosion will take place or rusting will take place, because this portion will act as a anode. So, let us take this. If a metal rod is dipped in electrolyte, so a portion dipped in water is comparatively poor in oxygen concentration, so it will work as an anode, so which get corrode, and the portion above the water, it act as a cathode. So, a very important example, a zinc rod is half or partially dipped in its solution, let Zn chloride. So, here we see that the portion which is above, which is open in atmosphere, it will act as a cathode, and the portion which is under this solution, it will act as an anode. So, the rusting will occur where the oxygen supply is less. So, in this case metal is same, but the concentration is different, and that is why it will act as a concentration cell. Now, next is factors influencing the corrosion. So, there are two important factors, first is nature of metal and second is nature of environment. The first, nature of metal. So, these are the factors: the positions in electrochemical series, hydrogen over metal, purity of metal, the relative area of anode and cathode, physical state, nature of oxide film as we discussed in chemical corrosion, and the volatility and solubility of corrosion product. Now, the effect of environment, temperature. Here we see that as we increase the temperature, the corrosion rate get increased. Humidity, moisture always accelerate corrosion. Impurity, pollution. If pollution is there, the corrosion will be fast. pH, in acidic medium, corrosion is fast. So, we can say less pH means corrosion more. Nature of ions present, conductance effect, oxygen concentration, cell, polarization or flow of process stream. So, I finished this lecture here, and in this lecture I will explain the prevention or protection against corrosion. Thank you.